Definitions. The principal is the original amount of money that is borrowed or loaned. Interest is an agreed amount which is paid when the original loan is repaid. Interest is determined using the equation I equals P times R times T, or interest equals principal times rate of interest per year times time in years. For example, if the principal is $2,050, the rate of interest per year is 15%, and the time period is 3 years, then the equation is interest equals 2,050 times 0.15 times 3. This equals $922.50. This means that the total interest over 3 years is $922.50, or $307 per annum. Per annum is Latin. It means per year or each year. Appreciation means increasing in cost or value. Inflation rate is the rate of increase of prices within the economy. Simple interest is the amount of interest paid based on only the original amount lent or borrowed. Interest that involves accumulating interest is compound interest. Flat rate is another word for simple interest. Exponential growth is the increase in growth after a successive time period, with interest added annually. Exponential decay means something decreasing by a smaller amount with each successive time period.
What is meant by a compound interest? Compound interest is based on the idea of simple interest, but is designed to make the amount owed increase over time. The interest grows by increasing the principal. To calculate the principal per annum, the interest of the principal is calculated at the end of the time period, in this case a year, then adding that figure onto the principal. This total figure then becomes the new principal for the next time period. An example. If someone loans $1,000 with a per annum interest of 8%, then their total investment at the end of the year is $1,080. This is worked out by the equation interest equals principal times rate of interest per annum, in decimal form, times time period. By this equation, the principal at the beginning of the next year is $1,080, and the interest is still 8%. Therefore, the amount of the investment at the end of the year is $1,164.4. This then becomes the principal for the third year of the loan. In the third year, the total investment would be $1,259.71.
How is simple interest different from compound interest? The difference of simple interest from compound interest is that the principal is constant throughout the loaning period. For example, if the person in our first example takes a simple interest loan instead of a compound interest loan, the equation for the first year is still principal times rate of interest per annum times time period. However, this remains constant for the second year and the third and the rest after that. Compound interest benefits the person whom money is being borrowed from, whereas simple interest benefits the person taking out the loan. As a side note, in regards to equations, the important difference to note between simple interest and compound interest is A. The simple interest formula gives the amount of interest, and B. The compound interest formula gives the total amount at the end of the compounding period.
When the interest is added annually, the equation for interest that is added annually, also known as exponential growth, is A equals P times 1 plus R in brackets to the power of n. This is when A equals the amount of loan after n years, P equals the principal, R equals the rate of interest per annum as a decimal, and n equals the time in years. For example, if P equaled $50,000, R equals 0.04, and n equals 5 years, then the equation would read 50,000 times, in brackets, 1 plus 0.04 to the power of 5. Therefore, A would equal $60,832.6451, or $60,832.65 over a time period, or $12,166.53 per annum. Another equation is I equals A take P. This is when I is equal to the compound interest earned or owed after a certain number of years, A equals the amount of loan or investment after the same number of years, and P equals the principal. Therefore, if A equals $70,000 and P equals $300,000, then I would equal $700,000 take $300,000. Therefore, the interest added annually is $400,000.
More often than annually. Interest on a loan may compound daily, monthly, quarterly, or every half year. Therefore, one must take into account the modified compound interest rule. where a quarter equals 12 over 4, or 0.03, a month is 12 over 12, or 0.01, and a day is 12 over 365, or 0.000329. However, when working out daily compounds, the fraction should always be kept in the equation.
Growth and decay. Examples of growth and decay include population, economy, and consumerism.
Exponential growth is the increase in growth after a consecutive time period, with interest added annually. The equation is A equals P times 1 plus R to the power of n. An example of a growth equation. The initial number of people hiring a hot air balloon for a wedding each year in Norway is 222. How many people will hire a hot air balloon in 4 years if the number of people hiring increases by 17% each year? The equation A equals P times 1 plus R to the power of n, where P equals the initial number, 222, A is the accumulated total number after a certain time period, R equals growth rate, 17%, and n equals number of years, 4. Therefore, the equation reads A equals 222 times 1 plus 0.17 to the power of 4. Once this equation has been worked out, the answer is A equals 416.0029606. Therefore, 416 people will hire a hot air balloon in 4 years' time if the initial number of people who hire per year increases by 17% annually.
An example of a decay equation. The initial number of people to climb Mount Vesuvius was 300. How many people will there be 3 years after it erupted in AD 79 if the number of people who climbed decreases by 100%? The equation for this problem is A equals P times 1 take R to the power of n, in brackets. This is adapted from the formula Vt equals P times, in brackets, 1 take R to the power of n, which is the general formula for depreciation questions. In the first equation, A equals P times 1 take R, in brackets, the power of n. A equals the decreased total after a certain time period, n. P equals the initial number, or the principal, which was 300 people. R equals the rate of decay in decimals, 100%, therefore 1. And n equals the time period, or 3 years in this example. Therefore, with these facts, the equation reads A equals 300 times, in brackets, 1 take 1 to the power of 3. When working out this equation, the answer is A equals 0.
To recap, we have covered a glossary of borrowing and lending words, compound interest, simple interest, interest when added annually and more than annually, and growth and decay.
We have covered the equations for compound interest, the amount of investment at the end of each year, simple interest, growth, and decay.